Hey, what's up, everybody? We are going to do a very specific kind of problem by request of linear functions. Okay? So I've got a word problem. I'm going to read it for you, and I'm also going to show you my shorthand. This is pretty common in the world of teachers. Hopefully you can read my handwriting. Write the equation, EQN, of a line that goes through the point -1, 6. I need to do a better job with my 6. -1, 6, and is perpendicular to y equals 3x minus 5. Answer needs to be in standard form. Okay? I could print that. We're very old school here. There's no, learning doesn't need all this technology. I mean, I appreciate this technology, but it doesn't need it. Okay? So write this down. Screenshot it if you need to. Write the equation of a line that goes through the points -1, 6, and is perpendicular to y equals 3x minus 5. The answer's in standard form. Okay, so right off the bat, you need to ask yourself, what are the key ingredients to unlocking this code? Okay? What are the key ingredients? So you need to know what perpendicular means. That's very specific. That's very specific. And you also need to know what is standard form. Okay? So let's say you're studying for a test, and you're like, you go over this problem, okay? And you immediately go, I don't know what perpendicular means, right? Look it up. Look it up. It's not rocket science, you guys. Perpendicular means 90 degrees. Now, there's a whole host of stuff in geometry with perpendicular, right? Right angles. I could go on and on and on and on, but we're trying to be short today. Pretty much any angle you see in your world is a right angle. It's perpendicular, okay? The square corners, those are perpendicular, right? That line is parallel to that line. That line is parallel to that line. Peekaboo. Okay, so perpendicular means this, right? And then you say, what does perpendicular mean with a linear function? Hopefully you know that, but if you don't and you're studying, look it up, okay? I'm going to say a word you're all going to love. Perpendicular in the world of linear functions means that it has a what kind of slope? It means it has the negative reciprocal. So reciprocal in the world of math means if you have A over B, that becomes B over A. And then negative reciprocal does not mean it's always going to be a negative slope. It means it's the opposite slope to whatever you had. Okay? So if your slope was -2/3, the negative reciprocal of -2/3 is positive 3/2. Okay? So the negative reciprocal simply means, and I'm going to write this quickly, okay? This is the negative reciprocal. If you have A over B, that means it's negative B over A. But this negative means an opposite, because two negatives make a, everyone say it with me, positive. So if your original thing is negative, here we'll switch it again. If I have a slope of -3/5, my reciprocal is 5/3. Negative of a negative is a positive, so it's positive 5/3. Okay? That's a little sidebar on reciprocal. But so you need to know that perpendicular means 90 degrees to what you have, and that you want the negative reciprocal slope. Okay? So then part 2, as you're decoding the question, you want it perpendicular to this line, right? Do you need to know about the -5? Is the -5 important to you? Because perpendicular only has to do with slope. All you're pulling from your line that you were given is the slope. 3x minus 5. Where's the slope? It's the 3, right? So now as we're decoding this, you're looking for a line that is perpendicular to this. So that means your slope is, this is 3/1. That means we currently have 3/1. Negative reciprocal means that we're going to have a slope of -1/3. Rock star. Okay, next step. Ooh, we've got our slope. We're given a point. Boom shakalaka. What are the three forms of the line? And again, if you're studying this, you're told standard form. You might go, what? Use the internet to your advantage. Google it. Standard form, slope-intercept form, point-slope form. You can just go right to point-slope if you want. Let's just do it. Okay, so point-slope form, hope you guys know this, is y minus y1 equals mx minus x1. Right? Are you with me on that? We'll do slope-intercept too, and you'll get the same answer. We'll do that second, okay? Oh, I'm looking at the wrong. So we're going to swap out what we know. I'm going to swap. You can swap the same. Y minus 6 equals negative 1/3 x minus negative 1. Boom. Okay, now I fielded this question a lot. Why did I put this negative in an extra parentheses? Because I want to show to you that the form, not the formula, the form stays. The form is a minus. This is a negative. Okay, kids, I love you guys. Your teacher needs to know that you understand that. I am a teacher. When kids do this, I'm like, okay, they get it, right? If they skip right to the x plus 1, right, because two negatives make a positive, I go, I think they got that, but that may have just been a typo. You want to prove to your teacher you get it. Okay? So let's write the next step. I'm going to drop the parentheses. Y minus 6 equals negative 1/3 x plus 1. Okay? Balanced line. Should we draw it in here? I want you guys to follow along at home while I do the same thing here. Okay? So we have y minus 6 equals negative 1/3 x minus 1/3, right? Because negative 1/3 times 1 is negative 1/3. You with me? Let's keep going. Uh-oh. Let's look at that again, shall we? Okay, I could have done something, but I didn't do it. Okay, now let's pause. Do you want to do more work than you have to, right? This is where kids stop when they're asked to clean their room and they're like folding their clothes. Like the dutiful child would fold their clothes and make sure that it's put away in the right drawers because grandma's coming, right? But some kids are like, what does mom really care about? Mom cares that the room looks clean. And there's room under my bed to shove all this stuff. At least that was never me. I promise you it was never me. Scouts honor. But I knew some people. It's horrifying. All they did is shove it under their bed. We all know who those people are. But in this regard, you're like, do I really need to do all this work to get it into standard form? What is standard form? Hopefully you looked that up. AX plus BY equals C. We've talked about this before. We're going to talk about it again. A, B, and C. Capital letters mean that A, B, and C need to be integers. Well, now you're deep in the rabbit hole because, Thompson, what's an integer? You remember all those things you learned about numbers, like greatest common factor and least common multiple? Yeah, those are super duper valuable. There's a reason you go over them over and over again. Because if you learn how to do that, if you learn how to see it quickly, math becomes infinitely easier. See, what people don't seem to understand as they start to get challenged in math in middle and high school is that all that stuff mattered. All that stuff mattered. You know, as you let's say you play basketball and you're really good at like pickup ball, right? And then you're really pretty good in middle school and you're like trying to shoot and play like Jordan, right? But you don't have fundamentals, right? You just have a lot of razzle-dazzle. You can get away with that for a while. But then you get to high school where kids have both the razzle-dazzle and the fundamentals, and you're going to lose, right? Let's say you make it all the way through high school, then in college, boop, same thing. Now you're going to go to the NBA. You have to have the fundamentals. Razzle-dazzle only gets you so far, okay? Math is no different. You can find smokescreen ways, but at the end of the day, it's you. It's you who knows it or doesn't know it, okay? So, if you have to go back and learn it again, there's no shame in that. You can use the internet. Come to me, ask me, but learn it and look it up. And if you get to a space where you're like, I don't know what that means, look it up. So standard form, A, B, and C, when you have capital letters in math, that means it needs to be an integer. It's a code. It's a language. I speak the language. I'm fluent in mathematics, okay? I'm fluent in mathematics. I'm telling you how to undo the code because I promise you, you already understand the ideas. I promise you, you already understand the ideas because the ideas of mathematics are all around us. You just don't speak the language, but I do. So A, B, and C have to be integers. What is an integer? It is what kids commonly refer to as a whole number, but it's not a whole number, it's an integer. Okay, back to it. Now, do we need to do all that messy work with fractions? Or can we multiply by a single number to get integers? In fact, we can multiply by a single number. And what number are we looking for? Now, these both are thirds. But in general, you are looking for the least common multiple, aka the common denominator, which is 3. So we're multiplying everything by 3. Everything across the equal everywhere. Okay, I'm going to do it here. You do it there. Okay, you have to do your work too. Okay, so I'm going to put a big 3 everywhere so I don't forget. Times 3. Okay, you see? I just did real big. Times 3. And I say all of it is times 3. I'm zooming in. I'm zooming. You know this. You know this. I'm on my picture, right? I'm on my Insta. I'm zooming in. What is that back there? Okay. So let's do it. 3y minus 3 times 6 is 18 equals 3 times negative 3 is negative 1 minus 1. Okay. Now you might quickly have realized we actually could have multiplied by 3 right at this step. We could have. And in fact, I just out of habit, even after all these years, I went and did the distributive property out of my habit. Okay? So if you went into the distributive property and then you later on were like, well, that was a waste of time, you're correct. This is why we have higher order, like, hey, I understand this and I see it. Okay, but let's finish this out. So we got to red rover some of this. So where's our equal sign? Right there. And there's our equal sign in standard form. The key to standard form is that x and y are, excuse me, x and y are on the same side. Now, here's our equal sign. Are x and y on the same side? They're not. They're not. They're like the Democrats and Republicans right now. We need them on the same side. Come on, guys. Be on the same side. So let's get them on the same side, you guys. No problem. In math is so much easier than in real life. Okay, so we just need to add an x. Adding an x. Bada boom, bada bing. Now I want x first. So I'm going to put x first. So I'm going to say x plus 3y minus 18 equals negative 1. Zonka donka do. Are you with me? Do you see this? So I moved x. Now I put x here, but I put it in front because that's how it goes with my standard form. Now I've got to add 18 to both sides. And survey says, final answer, x plus 3y equals 17. What did I just find? I just found the equation of a line, the equation of the only line that is both perpendicular to this and goes through that point. And you did too. Good job. So, what are our lessons for today? We need to have, did you ever watch He-Man? You need to watch He-Man. Orko would come in at the end and say, what were our lessons for today? If you're Gen X, I know you're with me. So, let's have our little lessons of the day, okay? What are our lessons of the day? Well, if you don't know what it is, look it up. Vocabulary is so important. Don't just say, okay, I'm gonna help you guys with, I want you to practice something right now with me, okay? When you practice something with me. I don't know yet. I forgot that. Can you tell me again? I didn't understand that the first time. Can you please explain it again? Those three phrases will go a long way with a teacher, and they'll go a long way for you. Because learning how to learn will never leave you. Math will pass away. It actually won't, but you know what I mean. Math class. but learning how to learn will never pass away. So here's our lesson for the day. If you don't know, look it up. If you can't find it, ask for help. And if someone, like a classmate or a parent or a teacher, tries to shame you for asking, then come to me. Because I never let that fly. I stick up for the little guy, always. Okay? Happy math. Love you guys. You can do it. It's the language. We're going to decipher it together. Have a good day. Miss Thompson is clicking off.